Motion is undoubtedly an indispensable part of our lives. We see people and cars moving on the ground, birds and airplanes in the sky, fishes and ships in the sea. Understanding motion is thus a natural start towards understanding how the world around us works. How do we know that something is moving? The choice of frame of reference for thinking of motion depends on the situation. For a car, the most convenient frame of reference is the Earth's surface. For a sailor, it is the deck of a ship, and for a planet, it is the sun. All motion is relative to a frame of reference. Once we have identified a frame of reference, we can describe the object's motion in terms of several useful quantities like speed. Remember that a speedometer does not measure average speed. It measures speed at an instant. What is the speed shown by the speedometer in the picture? In what unit is speed expressed? A car that has covered a distance of 60 meters in 60 seconds has an average speed of 1 meter per second. We usually describe motion by the qualitative terms fast and slow. Speed is a quantitative description of motion. If we indicate the direction of motion with the speed of an object, we are referring to the object's velocity. The average velocity of the race car in our example is 1 meter per second, eastward. Moving objects can have the same speed but different velocities. Describe the speeds and velocities of the two cars. The speedometers of the two cars indicate that they are moving at a speed of 10 meters per second. However, since they are traveling in different directions, their velocities are correspondingly different. Notice that in this example, we assume that the speeds of the cars are not changing in the duration of their travel. We say that they are moving at constant speed. In the real world, few objects move at a constant velocity for very long. For instance, when you ride on a bus from your house to the school, you would observe that the bus would sometimes speed up or slow down. It travels straight along highways and turns along bends on the road. The rate of change of velocity with time is what we call as acceleration. Since acceleration refers to the change in velocity in a time interval, it is important to remember that an object moving at a constant velocity has zero acceleration. There is no change in the speed or direction of the moving object. The following illustrations show the conditions for an accelerating object. All three cases shown reflect a change in the velocity of the object. Therefore, the objects shown are accelerated. Recall that we can change the speed and direction of an object by applying a force. These changes correspond to a change in the velocity of an object over a time interval. This means that force causes acceleration. If you have two objects with equal mass and you apply greater force on one, what can you say about their accelerations? If you have two shopping carts, A and B, in the supermarket, and they have equal masses, when you apply greater force on shopping cart A, it would then move with a greater acceleration than B. What if you apply the same force on both shopping carts, but you placed more products on shopping cart A, thereby increasing its mass compared to shopping cart B? What can we say about their accelerations? If you want both of your shopping carts to move with the same acceleration, you have to apply greater force on the heavier cart. To move two objects with the same acceleration, the one with a greater mass requires greater force. We now see that the acceleration of an object is related to its mass and to the net force acting on it.
The speed of a moving object is the rate at which it covers a distance. The speedometer of a vehicle measures the speed at a specific instant, the instantaneous speed. The average speed of an object that has traveled distance d in the time interval t is given by average speed, or v, is equal to distance traveled, or d, over time, or t. The SI unit of speed is m/s. Velocity is a description of an object's motion that includes both speed and direction.
Acceleration is the rate of change of velocity with time. It is given by acceleration A equals to change in velocity, or v, over time, or t. The SI unit for velocity is m/s. Acceleration is change in velocity per unit time, so it is expressed in meters per second squared. m/s squared. The acceleration of an object is proportional to the net force applied to it and inversely proportional to its mass. In equation form, acceleration, or A, is equals to force, or F, over mass, or M. Answer the following questions on a piece of paper. You can check your answer by pressing the